And then we can deal with x.
A little too big.
Yeah. And then we change x to become after return value address, and y is after x. So that part is correct. So are there any questions so far about the, yep?
Why would you have a problem with that? Like, if you kept everything the same way, and you accounted for that in your program, why would that be a problem?
It won't work. Because, okay, who dictates, these offsets? The caller, right? The caller, is already imposing a structure on the memory content on the stack. So as a callee, as a function or procedure being called, you don't have a choice but to play by the rules. If you do not play by the rules, then you will just be accessing, the incorrect information at the wrong part of the memory space. Okay, so that part is done, and then we look at the entry code and the exit code. Okay, somewhere in here I use EBX. And I hope most of you already know that EBX is an important register. It has to be preserved just like EBP. Okay? So here we have EBX being saved at the beginning here, and it is restored at the end over there. Is that okay?
Why is it?
Because I have to reserve, I have to save and restore EBX. What? Okay, is this okay, first of all?
No.
It is okay from the perspective that we will, save and restore EBX correctly. But it will mess up something else. What does it mess up in this case? It will mess up the differences, or it will mess up the offset from the EBP to the various components on the stack. At this point, you have two choices. You can either redefine all those definitions up there, okay, and basically add 4 to everything, because now we have one more register saved before. You can basically change all the offsets, or you can move the push and the pop so that it does not interfere with the way we count offset from where EBP points to. Is that making any sense? Okay. So the easiest way, I think, is to put pop EBP over here and push EBX over here. Okay? Because if you don't do that and you keep the definitions of the labels the same way, then the labels will be completely off they will all be off by 4 bytes. It will all be off by 4 bytes because pushing EBX will consume 4 more bytes. And then you take a snapshot of the ESP.
Unless you have local variables, then you would have to account for that.
If you have local variables, then you have to account for that too. So basically, it will mess up the way we calculate the offset from where EBP points to the various components. So instead of fixing all of the other things, we can just change the order of pushing and popping EBX and be done with it. Okay? So I think this is a really, really easy solution to fix the problem, and still accomplish what it has to do, which is to save and restore EBX. All right. So at this point, what are we doing? I am moving return address into EBX, okay? But I'm using a $ here, which means it is an immediate operand.
It has to have some kind of dereference.
Well, it has a dereference down here using EBX.
Okay.
Okay.
Oh, okay.
So what is the intent of these 3 lines as a whole?
Yeah. What is vector x?
Vector x is the displacement of member x from the beginning of a struct vector, which is our convention.
Oh, okay.
Okay.
Let's see.
Okay.
So you're trying to find
So I
that
want to see
member.
the C code.
You're trying to find that member in the return value is what's going on.
I am trying to
Find that
initialize.
address.
Okay, how about this? Okay, in the actual test, if I gave you the intention of the following
What
3 lines,
initializing?
okay, the
Yeah.
intent of the following 3 lines is to initialize member x of the structure pointed to by the return value pointer. Okay, so if I tell you ahead of time that's the intention of the next 3 lines, what would you do? You know, first of all, is it doing what it is supposed to?
Looks like it is. X is moving into
Is
EAX.
X an integer or a structure? The
Hmm?
value is,
X is an integer. X is an int. Yeah, vector has X as int and Y as int as well.
okay.
Okay. So okay, but let's just take a quick look here. What are we actually doing? Return value address. What is it defined to be?
It's defining
12,
the,
I think.
that's defining the beginning of the.
I think it's
return.
defined to be 8.
Eight.
Yeah,
Eight.
it's supposed to be 8. So this is a number 8. We put it into EBX,
Okay.
and then later on, you know, we say 8 plus vector x. I think x is 0. So it is basically 8 plus 0, which means 8. So we are trying to put the content of EAX into location 8. Does that seem right to you?
No.
It is not right because it is missing something. What is it missing?
The addition of the EVP.
The addition of EVP. Very good. Okay. Well, it's not just that too. What are the 4 bytes at return value address displacement from where EVP points to? What exactly are those 4 bytes? Are those 4 bytes the structure itself?
No, where.
Oh, it's gotta be dereferenced.
Where the location.
So we need a dereference first.
Which
Okay.
means you need to go return value address, parentheses EVP.
So if you cannot add new lines or you have to do the minimal changes to this program, how about we change it like
Yeah.
that? Okay, what would that do in return? What is this going to do?
But you now have the structure, but you still have a pointer to the structure.
Okay, well, let's just comment each line. Okay, what we want to do is to comment each line and find out what each line is doing. Okay, after we fix this line, what is going to be EBX after this instruction executes? EBX becomes a pointer pointing to
Return.
a struct vector that is in the return value area. Okay? So after this instruction executes, EBX points to the return value area, which is the same size as a struct vector. Is that okay so far? Making sense? This one is relatively easy. EAX is parameter x, right? I mean, that one is fairly straightforward. How about this one? We are putting parameter x to somewhere. Where am I putting it into? EBX is a pointer to a struct vector already, right? We have established that from the
Right.
previous step,
We're putting it in the location for vector x, which is where it would.
which is what we wanted, right?
Want it to pass
Exactly.
back, yes.
So in this case, member x of the struct vector of the return value area is initialized
So in the,
to x.
for the exam, we're not allowed to add any lines, we just can change.
You have to do the minimal changes. If you make more changes than that is necessary, then I can basically take points off for that.
I assume comments don't count.
Comments do not count. Yes, you're correct. You can add as much comment as you want, but actual instructions will count.
You didn't say anything.
Sorry? Okay, so are we okay with this one? Now, once we know this problem here, how about the second one? Is there any